Hello students, how are you doing? I hope everybody is fine and preparing well for the exam. Okay, welcome to my YouTube channel Ecstasy of Physics. Before going to main discussions, let me introduce myself. I'm Subhashis Nandy. I have done my PhD from IIT Kharagpur. In this video, we are going to talk about the shortcut tricks which can be applied in Kirchhoff's law. Generally, in Kirchhoff's law, we'll be having that multiple number of equations which will be time consuming to solve. To get rid of these situations, if we can prepare the less number of equations, then it will be easier for us to solve in competitive exam. That's why here we are going to apply the nodal analysis method. By the help of the nodal analysis method, the number of equations will be having that will be less. In this problem, we have to find out the current in the 3 ohm resistance. So in this network, to solve this type of problem, we are familiar that we have to use the Kirchhoff's law. We know that there are two Kirchhoff's law, that current law and the voltage law. But in case of applying the Kirchhoff's loop law here, it will be forming the large equations and that will be time consuming to solve in competitive exam. So instead of that, we can apply the nodal analysis method that you may consider is the applications of the Kirchhoff's law. So the method we are going to talk about, that's the nodal analysis method. In case of nodal analysis method, first we have to define the nodes. The nodes, it may be defined as where 3 or more than the 3 branches are made together in this network. So here we can define there are two nodes, A and B. Now one of the nodes in between A and B will be considering as the reference node or the zero potential node in case of nodal analysis method. So let's consider B as the zero node. So VB is becoming 0. So here we'll be defining this is the 0 volt, and at A we'll be defining this is the VA. These are the points connected with this 0 volt. That means this is also 0 volt and this will be also having the potential 0 volt. Now the 4 volt battery, the 0 volt terminal is connected here. That means this side should be 4 volt, and in case of this battery also, this side should be 4 volt. Now as this is a higher potential, so the current will be flowing along these directions. Let's consider this is I1 current, and in case of this 4 volt battery, it will be considering as a I2 current. So through this 2 ohm resistance also I2 current is passing. Through this 3 ohm resistance, the I1 current is passing. Now this is through the same, it will be passing through here the I1 current towards the A node. Now in between A and B, so let's consider the directions of the current. As VA is higher than 0 volt, so it should be flowing along this direction, I3. Now according to Kirchhoff's current law, here I1 and I2 current is, these are the current entering, and I3 current is coming out. So from here we can say it's I1 plus I2, that is equal to I3. Now let's define this I1. So I1, to define this, in this sections we can say there is a 4 volt battery and this is a 2 volt battery, and they are connected in the same polarity, which means, and throughout the resistance is 3 ohm and 2 ohm, those are connected in series combination. So here we can write, to define this I1, this 4 volt battery and 2 volt battery, those are connected in same polarity, series combination, so 4 plus 2, and potential difference at the point, potential at the point A node, that is VA. So it's the potential difference upon 3 plus 2, that is the net resistance in this section. I2 which is current supplied by this 4 volt battery here to the right side. So for this sections, this 4 volt battery and in between 2 ohm resistance is connected, and the potential at the point A node is VA. So you can write V, that is equal to 4 minus VA upon 2. That will be defining the current I2. And for I3 is the current which is produced from the A node and it is passing towards the B node. which is having the 0 potential. In between the 2 ohm resistor is connected. So here I3 can be defined as VA negative 0 upon the resistance, that is 2 ohm. So it is becoming 6 minus VA upon 5 plus 2 minus VA upon 2 equal to VA upon 2. So it is becoming 6 by 5 plus 2, and if we can bring this VA upon 5 plus VA upon 2 plus VA upon 2. So from there it's 6 plus 2, that means 6, 10 upon 5, and this is VA on 5 plus VA. It is becoming 6 VA on 5, that is equal to 16 upon 5. So from there we can consider VA will be getting 16 upon 6, that is 8 by 3 volt. Now we have computed here, that is VA equal to 8 by 3 volt. So from there I1 easily we can find out. I1 already we have got the equations. I1 equal to, it's 6 minus VA upon 5, that means it's 6 minus 8 by 3 upon 5. So it is 18 minus 8, so it's 10 by 3 into 5. So it's 2 by 3 ampere. That is the amount of current which is passing through the this 2 ohm and 3 ohm resistor. In this problem we have to find out the branch currents in the circuit. In this problem also we are going to use the nodal analysis method to solve this problem. So in that case, first we have to define the nodes. Here we can see this is the 3 branch of wire connected. So let's say this is the A node. This point will be defining as the B node, and let's consider this section where the multiple branch of wires are connected. So let's consider this is the our C node, which is becoming the reference node. So reference node we are considering here. According to this nodal analysis method, the reference node would be having the potential 0. That means it's also called as the 0 potential node. So VC, it should be 0. Now that means this point will be also having the 0 volt. These are the points, all will be having the 0 volt. With that, this battery is connected. That means this section will be 6 volt. This is the 10 volt battery is connected, so this part will be plus 10 volt. So in that case, this will be the battery will be supplying the current, let's say I1, and here is another battery 5 volt which will be supplying the current, let's say it's I2, and this is the 10 volt battery, so that will be producing the current, let's say I3. No need to be worried to consider the directions of the current, because in case suppose the directions of the current I2 instead of this towards this right hand side, if it is actually if it is the left hand side, then in that case automatically after solving this problem you will be getting the negative symbol, and that will be defining that the directions what we have considering here, that should be in the opposite direction. So no need to be bothered about that. Now this I1 current, what it is passing through this 6 ohm, after that at the point A node it is going to distribute it, so it is I2, and let's say the current which is coming to this 0 volt, that would be I4. And at the B node also the I3 current which is coming here, and after that I2 current is also coming to the node B, and let's say the current which is passing towards this section is I5. As this is a 0 volt, so we are considering this is a I5 current which will be passing from B node to 0 volt. So here if you are going to write down the current law, at the A node I1 current is entering. From here it is going to distribute it into two parts, is I4 and I2, and at the B node I2 and I3 currents are entering. So I2 plus I3, that is going to give the I5. Now to define this I1 we can say, which is produced by this 6 volt, and the 6 ohm resistance is there in between the A node and this 6 volt. And let's say at the point A, the node we are defining as VA. At the point B, the node potential, it will be VB. So I1 can be written as, according to Ohm's law, the potential difference, that is 6 minus VA upon the net resistance. So here the 6 ohm. If you are going to define this I2 will be in between VA to VB, it is passing, so it's becoming VA plus 5 volt battery minus VB, that is the net potential across the in between A to point B, and the net resistance is 2 ohm. Now to define this I3, that would be 10 volt battery negative VB, that is the potential difference at the B node, upon 4 volt. I4 current, it would be, which is passing from A to 0 volt. So here VA net potential is becoming VA minus B minus 0 upon 3 ohm resistance, so it is divided by 3. And I5, it can be written as I5, the current which is passing from the point B to 0 volt, that means it's VB minus 0 upon 4 ohm. So here we have defined that all the currents. Now after using this equation, I1 equal to I4 plus I2, so let's substitute in this equation. 6 minus VA upon 6 equal to I4. I4 is VA upon 3, and I2 equal to, that is VA plus 5 minus VB by 2. So here actually we'll be getting a relations in between the point A and B. 1 minus VA upon 6, that is equal to VA upon 3 plus VA upon 2 plus 5 by 2 minus VB by 2. Let's bring all the VA term together. So you can just write it down as, it's taking this VA by 6 to the right hand side, so it's VA by 3 plus VA by 2 plus VA upon 6, and let's bring this VB to the opposite side, so it is 1 minus 5 by 2 plus VB by 2. So here you will be getting, we can take as a common, so it is 2 plus 3 plus 1 upon 6, that is VB by 2 minus 3 by 2. VA into 6 upon 6, that is equal to 1 by 2 VB minus 3. So from there we can write down, it's 2 VA equal to VB minus 3. And similarly from the second equations, I2 plus I3 equal to I5, if you plug all the corresponding values of I2, I3 and I5 in these equations, after solving this you'll be getting VB minus VA upon 2, that is equal to 5. Now let's focus on this two equation. So this is the equation number 1 and this is the equation number 2. If you solve these equations, you'll be getting the value of VA and VB. And after solving this V and VB, if you plug in this equation of I1, I2, I3 all in these expressions, then it will be giving the values of all the currents, I mean passing through all the branches.
That's all for today. Thank you for watching my video. Any suggestions or queries if you are having, please share with me. I will definitely get back to you. And please subscribe my channel so that you don't miss any notifications. Bye. All the best.